Okay, we're continuing with notes on basic probability. We're on page 73 of the note spiral. And once again, this is basic probability, and I'm going to emphasize that you please consider making the sample spaces. I think it makes a big difference, as does writing down the blanks. So 5 multiple choice questions, each with 4 possible answers, appear on your history exam. What is the probability that if you guess, you get none correct? So first off, we have 5 multiple choice questions. So basically I have 5 blanks. And I can get 1 wrong, 2 wrong, 3 wrong, 4 wrong. And there's 4 wrong answers, and there happens to be 5 with 4 possible answers. I'm sorry. So there's 3 wrong answers and 1 correct answer. So we have 3 wrong answers and 1 correct answers. What's the probability you get none correct? That means this one has to be wrong, this has to be wrong, this has to be wrong. Basically, all of them have to be wrong. All 5 of them have to be wrong. Well, what's the probability of getting it wrong? Well, 3 out of 4 possibilities. So I see 3/4 times 3/4. And pretty soon I go, oh, that goes all the way across. So I can go ahead and write it as 3/4 to the 5th power. If you do this and do this only, this is correct and will receive you full credit. Go ahead and give me a decimal response after you've written that. But this will satisfy your work. But I'm going to say that this is a really good way to start. And usually I notice by the time I get to the second number, it's like, oh, I can raise it to an exponent. And I just quit writing. I write it as an exponent. What's the probability you get all of them correct? Okay. Now we're going correct, 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 and I need 1 more blank. And we see that, okay, well, there's 1 out of 4 possibilities. So 1/4, 1/4, all the way across. So that's going to be 1/4 to the 5th power. This next one is probably one of, in my opinion, the at least problems, and based on what I've scored students on the test, is the most difficult problem for them to get. So first off, if you see at least 1, if you ever see that phrase, I want you to always think 1 minus, and I want you to do the opposite. So they asked for wrong, so we're going to work with correct. And I'm going to do this work on a little separate notepad just because I don't have enough room here. All right, so get at least 1 wrong. Well, the reason this is a difficult problem, or first off, what it means is we have basically 5 answer choices because we have the 5 blanks, 1, 2, 3, 4, 5 blanks. So I could get 0 wrong, 1 wrong, 2 wrong, 3 wrong, 4 wrong, or 5 wrong. But they said at least 1, so any of these would satisfy and the 0 would not satisfy. So in this case, if I get 1 wrong, that's good. I need to figure the probability of getting 1 wrong. What's the probability of 2 wrong, plus the probability of 3 wrong, plus the probability of 4 wrong, plus the probability of 5 wrong? I could do that, but it would take a very long time. And what if you had 20 questions on the test? Well, then this would be ridiculously long. And most people say, no, I'm not going to do that. But remember, the probability of all these probabilities sum up to 1. So I can do essentially 1 minus the probability of getting none wrong. Okay. That means a probability of getting them all correct. So here, if I want to get them all correct, well, how many choices do I have? Well, we have 5. So 1 minus 1/4, because we're going to be correct, correct, correct. We need all 5 answer choices correct. So, and then 1 more. 1, 2, 3, 4, 5. put a bracket around it. So if I were to show my work is this, that would be nice work because I know you knew what you're talking about. So 1 minus 1/4 to the 5th power. All right, 1 minus 1/4 to the 5th power. And the chance of that happening, very, very small. Okay. The next question, get your first incorrect answer on the 4th question. Well, I know they said 5 questions above, but right now they're only talking about 4. So here we go. 1, 2, 3, 4. Because they're not worried about the 5th one. They just said, hey, the 4th one. So stopping at the 4th one, they don't tell us what the 5th one needs to be. But this is supposed to be incorrect, so this has to be wrong. So the probability that an answer is wrong, because we had W, 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 C, okay, the probability of wrong is 3/4. But if this is supposed to be the first wrong one, that means these have to be all correct. So correct, 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 and then we get to our 4th one is wrong. So these are 1/4 times 1/4 times 1/4. Let's put this in parentheses as well. Okay. All right. The Master Foods Company manufactures bag of peanut M&Ms. They report that they make 10% each brown and red candies and 20% each blue and orange candies. The rest of the candies are green. So we have brown is 0.10, red is 0.10, yellow 0.2, blue is 0.2, orange is 0.2. When I add these up, 0.1 plus 0.1 is 0.2, 0.4, 0.6, 0.8. So green has to be 1 minus 0.1 plus 0.1 plus 0.2 plus 0.2 plus 0.2. Or 1 minus 0.8, and that needs to equal 0.2. So green is 0.20, or 20%. It is a primary color, red, yellow, or blue. All right. This means it can be red, it can be yellow, or blue. What was the probability? So we have 3 possibilities, 1, 2, 3, red, yellow, or blue. We have the word or that indicates add. All right, so 0.10 plus 0.2 plus the 0.2, and we end up getting 0.50 is our answer. It is not an orange. All right, well, I can do one of a couple things. I can add everything else up except orange. All right, I can add all these values up except orange, but not is a very interesting question because I can use 1 minus the probability of getting an orange. All right, so 1 minus the probability of getting an orange would be a lot faster. So 1 minus 0.2 equals 0.8. If you pick 4 M&Ms in a row, what's the probability they are all blue? So once again, we have 4 blanks, 1, 2, 3, 4, 0.2, 0.2, and like I said, I usually get to the second one, and I'm pretty smart at that point. So 0.2 to the 4th. None are green. All right, 2, 3, 4. Not green, not green, not green, not green. Well, the probability of not green is 1 minus 0.2 equals 0.8. So I have to have a bunch of not greens. And real quickly I go, oh yes, 0.8 to the 4th power. At least one is red. Oh, here we go. There's our favorite at least phrase. So at least one. And once again, This is a 1 minus. All right. And since they asked for red, we want everything but red. All right. So 1 minus not red, not red, not red, not red. Well, what's the probability of not red? Well, 1 minus 0.1 equals 0.9. So, but we're picking 4 in a row. So I need four blanks. So 1, 2, 3, 4. So 0.9 times 0.9 times 0.9 times 0.9, or 1 minus 0.9 to the 4th power. All right. The 4th one is the first one that is brown. So 1, 2, 3, 4. So these are not browns, not browns, not browns. This one is brown. So what's the probability of getting a brown? Well, the 0.1. So not brown is 1 minus. All right. And then finally, after picking 10 M&Ms in a row, you still have not picked a red one. A friend says you will have a better chance of getting a red candy on your next pick since you have yet to see one. Comment on your friends. Well, a couple things. If you have a single bag of M&Ms and you're taking them out and eating them just like I would do, then yes, your friend is right. If you've not drawn a red M&M yet, it's going to increase in likelihood the more you continue to draw. However, if you replace the bag, if you replace the M&Ms into the bag, then the probabilities didn't change and your friend is incorrect. And as I mentioned in class, if you have an infinitely large or a large enough population of M&Ms and a small enough sample, we say that they are independent even though they are not, because the probabilities change by so little. Okay, all right, so that will take care of page 73, and we will continue on in the next video.